Hello guys. Today we're going to talk a little bit more about what exponential functions are. I'm just going to give you kind of an idea of what they look like. What is an exponential function? So an exponential function grows very rapidly or decays. Grows or decays very rapidly. Again, these are notes, so you should probably be writing them down to practice being a good note taker. Always write it down, replay anything that doesn't make sense, and write down things that you think were important that I said that I might have not written down. So make sure you're writing this down. So what makes an exponential function? I didn't really answer the question. I just kind of gave you a characteristic of an exponential function, which is it grows or decays very rapidly. In math, we're going to see the standard form right here, which is y equals a times b to the x. Notice that a is just a number and b is just a number we don't know. Just like we have linear functions where it's like y equals mx plus b. That's the slope-intercept form of a linear function. We also have the standard form of a linear function, which is ax plus by equals c. Well, in exponential functions, we have that just as well right here, the a times b to the x. A is what we call our initial value. So that's important vocab right there, initial value. What is the starting amount would be another way to say that. Starting amount. Okay. Now, B is what we call the growth or decay factor. Okay. Now, these are important words that kind of give us an idea of how to describe an exponential function. So the growth or decay factor tells us a lot of important things of whether it's growing or whether it's decreasing. So over here to the side, I'm going to write growth factor. Growth factor means that the function is increasing. It is going up, right? The numbers grow rapidly. And that means that our b value has to be greater than 1. That means that whatever that b number is going to be, it's going to be greater than 1. If it is a decay factor, again, I'm hoping that you're writing all this down. If it's a decay factor, the b is going to be between 0 and 1. Notice that it's not equal to 1. It is smaller than 0 or greater than 0 or smaller than 1, but it's not equal to 0 and it's not equal to 1. And for the growth factor, it is bigger than 1. And these are just kind of simple facts. I wish we could have had more time to go in and explain it, but I'm here just trying to give you a general idea of what an exponential function is so that when you see it in the future, you're not confused. So that's kind of important parts about the exponential function. One thing that I always like to remember is that the next equals now, which means like our pattern is multiplication. And I'm running out of room here. So the pattern here is always multiplication, and you have to be able to distinguish that from a linear function. So let's go ahead and try this table down here. Copy down these tables. Make sure you leave enough space to answer each question. So copy these down, and let's go ahead and do the first one. These are my x values, and these are my y values. And this is a function. We're going to determine whether it is linear or it is exponential. If it is linear, it's going to have a rate of change. If it's exponential, it's going to have the growth or decay factor. In a linear function, we normally call it the y-intercept, and in an exponential function, we call it the initial value. Again, these two words are actually the same thing. So if we go back to the video up here, under that a, the a is the y-intercept, so we need to write that down. What you start with. I knew I was forgetting something. So make sure you write that down on the top. So let's go ahead and do this one. We need to find our patterns. Notice that the x's are increasing by 1. 0, 1, 2, 3. There's no tricky pattern here, so we're good on the x's. Now let's look at the y's, the function. This is our function. How is it changing? So from 2 to 5, 5 to 8, 8 to 11, and 11 to 14. What is happening each time? So from 2 to 5, that's plus 3. From 5 to 8, that's plus 3, plus 3. So if I am adding, this function is linear. It is not exponential. And since I'm adding, the rate of change, or my slope, because it's not a growth or decay factor because it's not exponential, my slope, which is the letter m, which is what we learned in class, is 3. And we have to determine what we started with. Our y-intercept is when x equals 0. And again, I'm pulling a lot of knowledge from what we did before. When our x is 0, what's my y-intercept? 2. And if we remember, the y equals mx plus b is the equation for a linear function. So we're going to put it all together, and I'm going to write y equals, and my slope was 3, and my y-intercept was 2. So that is the equation for that table. Because I knew it was linear, because I was adding, and I found the y-intercept because when x is 0, that's my y-intercept, which is what we need for the equation. So let's go ahead and try the next one. Try to find the pattern on this one. Is it adding or is it multiplication? Again, pause the video, try it yourself, and then go along with the video. So I assumed you paused the video and did that already. So let's look at the pattern. 1, 3, 9, 27, 81. Well, if I try adding, that's plus 2, that's plus 6. Immediately, adding did not work. So I'm not going to do adding. I'm going to try multiplication. Multiplying by 3, multiplying by 3, multiplying by 3, multiplying by 3. Again, you could use a calculator, kind of do some guess and check there. But this one has a pattern of multiplication. And because it has a pattern of multiplication, I know that it is an exponential function. So because it is an exponential function, it will not have a rate of change. Now, it's multiplying by a 3. Is it going to be a growth or a decay factor? So let's go back up here. A growth factor means that the multiplication is greater than 1. A decay factor would be if the multiplication is a decimal between 0 and 1. So let's go back over here. The multiplication is 3, so therefore this is a growth factor. And the growth factor is 3, or b equals 3. The initial value, which is our y-intercept, is where x is 0. When x is 0, my initial value is 1. So my a is 1, like that. And I'm going to use my equation, y equals a times b to the x, because that is the standard form of a exponential function. So we got y equals, we started with 1, and we multiplied 3 x number of times. So there's my equation. All right, let's go ahead and try one more. Try this one on your own. Be careful with this one. This one's tricky. Pause the video, and when you're done, continue playing the video. All right, so for this one, we got to look at the pattern. From 8 to 6 to 4, that's minus 2, minus 2, minus 2. Because I'm subtracting 2 each time, it is linear. Therefore, it is a rate of change. So we're talking about linear, which is y equals mx plus b. Remember that. That's linear. So my rate of change is negative 2, which is my slope. And my y-intercept is 8. Nope, it is not 8. This is where I'm trying to trick you. The y-intercept is when x is 0. If you look at your table, x is not 0 on there. So let me go backwards. If I go backwards, my y-intercept is 10. So this one, you had to work a little bit harder on the table to find the y-intercept. So we got y equals negative 2x plus 10. Because that's our slope and that's our y-intercept. And that's how we write exponential functions. All right, so that one was tricky because I didn't give you the y-intercept on the table. I made you try to find it. So let's go ahead and do this one right here. Go ahead, copy it down, try it on your own, pause the video, and then see if you got it right. So I assumed you paused the video. We're gonna go ahead and try. We got 50, 100, 200, 400, 800. Here, my pattern is multiplying by 2. And because it is multiplication, that means that this is an exponential function. And it has a growth or decay factor. It's times 2. So we put a growth factor, not decay, growth factor. So my b is 2. My y-intercept is where x is 0. X is 0 at 50, so this one starts with 50. So this is y equals 50 times 2 to the x, like that. And also one thing, you can't multiply these two and say it's 100 to the x. That's two very different functions, so do not make that mistake. Alright guys, so I'm going to go ahead and let y'all try the next two. Make sure you write these down and put them in your notes. I will be looking for them, so make sure you write this problem and this problem right here. I'm going to put this as problem number 1. Problem number 2. Again, pause the video, write it down, and you have some more. Problem number 3. Problem number 4. Problem number 5. And be careful with your x's. I'm skipping some. And some of these you need to find the y-intercept. So if you're pay attention, this one right here skips your x's. So that one's actually trickier. So just be careful because I'm trying to trick you there. Remember, you need to find the y-intercept when x is 0. So don't forget that for the tables. I will be looking for these in the notes. And if you have questions, email me and schedule a Google Meet so that we can do this together. Bye-bye.